This is solving polynomial equations in factored form. Factored form is when a polynomial is written as a product of factors. So it's still written as two factors that need to be multiplied. Whereas standard form is when you've already multiplied and you're writing it from the greatest degree all the way to the smallest degree from left to right. So factored form is before you've gotten to this type of answer. The zero product property says that if a product of two real numbers is zero, then at least one of the numbers is zero. So when you're trying to solve a polynomial equation and it's equal to zero, you want to use the zero product property to solve that polynomial. The roots are the solutions of a polynomial equation, and a repeated root is when you have two or more roots of an equation that end up being the same number, the same solution. So here we're going to solve some polynomial equations. So I know that if I'm multiplying 2x and x minus 4 and the answer is 0, that either, in this case, 2x must equal 0 or x minus 4 must equal 0. So if this is going to be equal to 0, x must be 0. 2 times 0 would give us 0. Or in this case, x might be 4. 4 minus 4 would give us 0. So x equals 0 and x equals 4 are the roots for this polynomial. So let's take a look at this one. We've got x minus 3 and x minus 9 equals 0. So if I'm going to get this answer of 0, either x minus 3 must equal 0 or x minus 9 must equal 0, which means x is either 3 or x equals 9. So x equals 3 and x equals 9 are the roots for this polynomial. There are potential solutions. So let's try a few more complex ones. Same concept here. I'm multiplying 2x plus 7 and 2x minus 7, and I have an answer of 0, which means either 2x plus 7 equals 0, and that's how I'm getting that solution of 0, or 2x minus 7 equals 0. So in this case, x would have to be negative 7 halves in order for that to equal 0, or in this case, x would have to be 7 halves. So negative 7 halves and 7 halves are the roots for this polynomial. In this case, I'm doing x minus 1 squared. So x minus 1 times x minus 1, and I'm getting an answer of 0. So either x minus 1 equals 0 or x minus 1 equals 0. So in this case, x would be 1 or x would be 1. In this case, since they're the same, we just say x equals 1 is the root. It's a repeated root, which is why we only really end up with one answer here. And let's take a look at this one. This one we're multiplying 3 different terms. So x plus 1 is either equal to 0, or x minus 3 equals 0, or x minus 2 equals 0. So x here could be negative 1, or x could be 3, or x could be 2. So x equals negative 1, x equals 3, and x equals 2 are the roots. To solve a polynomial equation using the zero product property, we may need to factor the polynomial or write it as a product of other polynomials. Look for the greatest common factor of the terms of the polynomial. It will be a monomial that divides evenly into each term. So here we have a problem. 4x to the fourth plus 24x to the third, and we want to write this in factored form. So we want to do the reverse. We want to get it back to two polynomials that we're going to multiply to get this answer. One way to do that is to find the greatest common monomial factor. Well, you guys have done greatest common factor before, so if I just look at the numbers 4 and 24, their greatest common factor, the biggest number that goes into both of these, is 4. If I look at my variable terms, x to the 4th and x to the 3rd, well, the biggest thing they would share is x to the 3rd, 3 x's. So if I combine that, the GCF of the terms is going to be 4x to the 3rd, which means I want to take both of these individual terms and divide them by 4x to the 3rd. So 4 divided by 4 is going to give me 1. And if I'm dividing powers, I'm going to actually subtract their powers. So x to the 4th minus x to the 3rd, it's going to leave me with just x here. In this case, 24 divided by 4 is 6. And if I divide x to the 3rd divided by x to the 3rd, I get 1, which I'm not going to write down, so I get x plus 6. And all of this, to get back to the original form, would have to be multiplied by 4x to the 3rd. So in this case, 4x to the 3rd is the greatest common monomial factor, and I'm factoring that out. So I'm turning it back into factored form. So sometimes we have to turn something back into factored form in order to be able to solve the problem. So I know that here something has to be equal to 0. But I don't have this written in factored form. So I'm going to find the greatest common factor to factor out. So 8 and 2's greatest common factor is 2. And x squared and x, their greatest common factor is a single x. So I'm going to divide both of these by 2x. That's what I'm going to factor out. So 2 divided by 2 is 1. X squared divided by x will just leave me with a single x. 8 divided by 2 is 4, and x divided by x, they'll cancel out. It's worth 1. So here is my problem in factored form. Now I know 2x has to be equal to 0, or x plus 4 has to be equal to 0. So x can be 0, or x could be negative 4. These are my roots for this problem. Let's try one more. Now this one is a little more complicated because it really isn't equal to 0 right now. But I can fix that by subtracting 15n from each side. So now I would have 6n squared minus 15n equals, since these cancel out, 0. So now I need to factor these. 6 and 15's greatest common factor is 3, so I'm going to divide both of them by 3. And n squared and n's greatest common factor is n. So I'll divide them both by 3n. So I'm factoring out 3n. 6 divided by 3 is 2, and n squared divided by n is n. And I'm going to minus here. 15 divided by 3 is 5, and n divided by n is 1. So 3n has to equal 0, or 2n minus 5 must equal 0 here. So n could be 0, or n could be 5 halves.